Let's start with this one here. We got Frank here. Frank's planning a party. He wants to spend no more than $400. The reception hall charges a $55 cleanup fee plus $15 per person. What's the maximum number of people that can attend the party, including Frank, and Frank remain within his budget? Jasmine, what you got?
22.
No. Sophia? 23. All right, so we got a couple things here. We got no more than $400. So we got $400, no more than. Can he spend $400 exactly? Yeah. Can he spend less than $400? Yeah. So we're looking at an inequality less than or equal to, okay? Then we got $15 per person, $55 cleanup fee. He's going to be charged the $55 no matter what. So we got $15 per person. I'm just going to put X on it. And we got the $55. So if we wrote the inequality, that's the inequality we're looking for, basically. So you would subtract 55 from the 400. You would divide by 15. And you get your X less than or equal to 23. It says, what's the maximum number of people that can attend the party, including Frank, and Frank remained within his budget, so he could have 23 people attend. So that's including him. So all he needs are 22 friends for his party. Okay? Now, if it said he wants to spend less than 400, then we would have to go 22 or lower. Any questions on that? All right, so let's look at a little different one here. We got Haley has 3 more than 2 times the many math problems for homework as Shelly. They have 33 problems together. Haley spelled her name differently twice. My bad. We'll pretend it's the same Haley both times. Aiden, how many problems Haley got? Huh? 23 is correct. All right, so I'm going to use, I'll use S just because we'll use Shelly. Haley has 3 more than 2 times as many math problems as Shelly. So 3 more than 2 times the amount of Shelly. Okay? Together, they have 33. So together means you would add on Shelly's. So if I add on Shelly's, I add on S, and it's going to equal 33. So if I combine those, I've got 3 S's, 2S and 1S, plus 3 equals 33. Subtract 3, divide by 3. That means Shelly would have 10. Well, we don't need Shelly. We need Haley. So 3 more than 2 times. So we go times 2. That's 20. 3 more makes 23. So Haley, both with and without the I, has 23 problems. Okay? Any questions on that one? Kind of like these kind of problems where it's just, you don't have to do the equation, right? But the equation, and you can kind of work your way through it mathematically. All right, this time, Haley again. We're going to stick to the I in her name. She got 4 tickets to the concert. At the time of the purchase, they had a special buy 1 ticket, get 1 ticket half price. Cost of the tickets was $174. We need to know the regular price. So I figured the first 2 were a little easier, so we'll get a little trick here. All right, so we're going to look at the prices on the ticket, okay? She bought 4 tickets, 1 ticket full price. So, if we go like 100%, right? 100% decimal, we got 1 as a decimal. Then, second ticket, we got 50%, half off, right? Third ticket, she's going to have to pay full price again, right? So 100%. Fourth ticket, whoops, I need a plus sign. 50%, right? Total amount she paid, $174. Everybody good with that part? You see what I did? Like we got full price, full price, half price, right? So when we combine all that, we got 1 half, 1 half. I got 3 total X's. I got 174. I divide then. That means 1X is going to equal $58. That's going to be the cost of 1 full price ticket then. And, if we went back and kind of looked at it, if I did, 58 plus 58, that's 2 full price tickets. Half of that would be 29 and 29. If I added all that up, that's going to give me that 174. Okay? All right, you ready for the tougher one then? All right, so Michael's going to sell some lemonades. Start making a profit. All right, so a little reminder. Profit is money made minus money spent. 70 is correct. All right, so a little more complicated here. The amount of money he's making 25 cents every time he sells a glass of lemonade, right? So his profit based on X glasses, if we want to write it like a function, we can write it like that, is going to be, 0.25 X. Everybody's good with that, right? That's how much money he's making. Now we need to subtract the money he's spending, okay? What he's spending is he's spending $16. Everybody good with that part? Right? $12 worth of lemons, $4 worth of glasses. That's not all he's spending though, is it? The part that makes this a little more complicated is the 2 cents of sugar every glass, right? So we need to account for that too. I could make this look a little more complicated. I'm just going to kind of make it look a little more simplified. And I'm just going to subtract that as another subtraction thing. So we got the 2 cents for each glass. Everybody kind of see that equation? So if you put that into Desmos, basically what you're looking for is where it's going to cross from a negative number or a negative y value to a positive y value. So we need this to go from negative to positive. And that's going to be like right around 70. I think it's like 69 point something or another. Which means, if they sell 69 glasses of lemonade, he's still losing money. And then he makes a couple cents once he sells glass 70. Probably not the best business model for Michael to make a lot of money. Any questions on that one? That's a little more complicated. Some of y'all probably do that a little differently too, right? There's more than one way to do a lot of these types of problems like this. There are ones you can do by writing functions or writing equations. There was ones you can do by working your way backwards, or you can do them by trial and error a lot of times. I don't know. They're the ones that are fun or interesting, maybe isn't exactly the right word, but a little more like kind of think your way through type problems where it's not, oh, this is an exponential function. I got to do this, this, and this. You know what I mean? So.